Hello, this is Brother Tony, and today we're looking at 6.1 to 6.4 exponential functions, nonlinear functions. So the objective for this lesson, define and explain the exponential functions, define and explain 5 properties of exponentiation, that's a mouthful, define and explain exponentiation for rational exponents. If I could draw your attention here, first of all, the exponential function is general equation y equals a times b raised to the x power. The first thing I want you to see is you have a times b raised to the x. The power only transfers to the b. So keep that in mind. That will save you a little bit of difficulty along the way. And then the second thing, let's look at this graph. So when x is 0 right here, what is y? Y is 1, and that'll be a definitional term. When x is 1, y is 2, because 2 to the first power is 2. When x is 2, y is 4. So basically, every time you go up by 1 in x, you are doubling the base, because it's to the power of 2. Go the reverse way. If you go from 4 to 2 to 1, you're dividing by 2. Keep that in mind. Keep that in mind, because no longer you don't have a linear slope anymore. And so you don't have a constant slope. You no longer have a linear equation. Okay, so let's get into this a little bit more. Okay, by now you know that you should be taking good notes in your notebook. We'll probably have a notebook quiz later on. So let's first of all start with the second definition here in the expression x raised to the r powers. So let's say we have x raised to the fifth, or x raised to the n power. So x right here is the base. This 5 right here is the exponent. And the total thing is called the power. Okay. So let's back up a second. And so now if we say x to the fourth, we have x as the base, 4 is the exponent, and x to the fourth is the power. In definitional terms, many times people use, including myself, the word power incorrectly. Power is the whole thing, x raised to the fourth. X to the fourth now can be rewritten as x times x times x times x. X multiplied by itself 4 times. The third thing, if the base of a power consists of more than one symbol, then it is to be placed in parentheses. Why? Because you saw in the previous slide that if we did y equals ab raised to the x, y equals ab raised to the x, the exponent, x right here, only refers to b. So if we do x times y to the fifth, that does not equal x, the quantity x times y to the fifth. This exponent only refers to this base unless it's in parentheses, then it refers to whatever is in parentheses. Knowing that, remembering it, using it is going to save you a lot of time. Okay, here are 5 properties of exponentiation. Let's go through each of them. So the first one, product of 2 powers with equal bases, x raised to the a times x raised to the b equals x raised to the a plus b. So here's an example. X to the fourth times x to the second equals x to the 4 plus 2, which equals x to the 6th. Makes sense. Why? Because if you write this out, x to the fourth is x times x times x times x. X squared is x times x. So it would be x to the 6th power. The second one also makes a lot of sense, as math generally does. Quotient of 2 powers with equal bases. X to the a divided by x to the b equals x raised to the a minus b. Let's take a look at this. X to the fourth divided by x squared equals x to the 4 minus 2 equals x squared. Why? Because if we did this, x times x times x times x, that's x to the 4th divided by x times x, we can cross out these, and that leaves us with x squared. Can we get one more in here? I think so. Power of a power. This, I don't know if you have favorite mathematical terms or mathematical expressions or whatever, but this is one of my favorites. A power raised to a power. Let's do x to the 4th squared. What is that really saying? That's saying x times x times x times x. That's that first one. And then we square it, meaning x times x times x, and I just ran out of space, times x equals x to the 8th. Another way of doing that is x to the 4th squared equals x to the 4 times 2 equals x to the 8th. A little cramped there, but you can see that, I hope. Here's another good one. Power of a product. So x times y raised to the a power equals x to the a times y to the a. So x times y raised to the 4th equals x to the 4th times y to the 4th. And then quotient. X divided by y raised to the a power equals x to the a divided by y to the a. That's not a 9. That's really bad. Here. Let's actually do an example. X over y raised to the 4th power equals x to the 4th divided by y to the 4th. Looking ahead, we'll actually say x to the 4th times y to the negative 4th. Interesting. Stay tuned. Here are 4 problems dealing with properties of exponentiation. Stop the video right now, put these in your book, try and work them out, and then when you're ready, take a look at the answers. So the first one, y raised to the 4th squared and then cubed. You multiply these and you get y to the 24th. And what property is that? My favorite one, power of a power. The next one, power of 2 powers with the same base, but then combination here. X cubed times x squared times y squared. You can combine similar bases, but you have to keep, if it's a different base, you keep it distinct. So x cubed times x squared is you add these two, 3 plus 2, x to the 5th times y squared. And then you distribute here, x, the quantity x times y times z raised to the 3rd power, x cubed times y cubed times z cubed, and then the quotient, x cubed divided by z cubed. I have a sneaking suspicion that many of you have seen up to now all of these properties of exponents. These may be a bit new, and I put them a bit small, so I apologize, but we'll go through this. The exponentiation for negative exponents. So if we have x to the negative 4, that's the same as saying 1 over x raised to the 4th power. And if we had 1 over y to the 3rd, we can rewrite that as y raised to the negative 3 power. You see, it works both ways. Here we saw that right at the beginning of this video where we had the graph, and when x, any variable, anything raised to the 0 power equals 1. 15 raised to the 0 equals 1. Z raised to the 0 equals 1. Exponentiation for reciprocal exponents. Wow. 1 over x squared is the same as saying x to the negative 2. But what does that really mean? It really means take the square root of x. And if, for example, this is 1 over x to the third, that says take the cube root of x. This one, exponentiation for fractional exponents. Pretty important, a lot of stuff going on here, so I decided to give it its own slide. So here we go, x raised to the 4/5 power is the same as saying take the 5th root of x and then raise it to the 4th power. Now, many times you will have something like this, and especially in the practice exercises, they'll give you something to the effect of 81 to the 3/4 power, which is the same as saying take the 4th root of 81 and then cube it. Now, what number raised to the 4th power equals 81? Well, that number is 3. 3 cubed equals 27. So what you want to do is you want to simplify first before you raise it to that power. So once again, I give you some practice examples. Stop the video right now and put these in your book. Go over them, and then when you're ready, start the video again. So let's do number 1. So 2 times x raised to the negative 3. Remember, the negative 3 power does not go to the 2, so we would say 2 over x cubed. Second one, pretty darn easy, I think. It's 15. Did you get that? Once again, the 0 power goes with the y, not with the 15. So y raised to the 0 is 1. 1 times 15 is 15. C to the 1/2. C goes there. Take the square root. 27 raised to the 2/3 power. Simplify first. We can write this as take the cube root of 27 and then square it. So what is the cube root of 27? 3, because 3 times 3 times 3 is 27. 3 squared equals 9. Okay, that's all there is. Hope you took good notes. Hope you understand this. We'll go over some harder stuff in class, but it's good to be ready. Okay, see you later.